Okay, now the other thing which I want us to look at is if I can tab v201, if you can see this particular variable has 0, 1, 2, 3, 4, 5, 6 up to 15. Now if your dependent variable is appearing like this, this type of behavior, we actually modeled using what is called Python regression, because this one is a count variable. So because it is a count variable, Python becomes the most feasible model that can be used to model that. So we normally use Python. So like normally Python, it is a count variable. So as a count variable, we can be able to use the ftest to check its part, its measure of association. For example, I can actually say v201 and the v106, which is education, and then I can be able to tab. So if I can be able to tab, this gives you the equation like a Python regression. So you can actually see the way it has been presented. So it has some values on that one. So Python, you actually use it for a limited dependent variable. Okay, and using the same, you can even do MFX as we have been doing to determine the marginal effects of that. Or sometimes you wanted to look at something inside, then you can actually look at I dot, and then you can actually check what could be the component within the variable. But you can actually see that when I did this, this was negative, but I've now noted which one has the greatest negative effect on that. Okay, so Python regression, if you can look at the kernel density, of v201, sorry, let me stop this process. Okay, kernel density, of v201. If you can take that one on board, kernel density of of that particular statement, if you can wait its processing, it is going to give me a situation where if you can see, it has so many zeros at the beginning, and the numbers are decreasing by time like that. So if it is appearing in this particular form, it means that the modeling part of that dependent variable is going to be defined as Python. So my variable I work at the frequency of eating food in a week, frequency of listening to the radio, number of children ever born, or times number of times you can be able to study in a week. So those variables that we are counting, the frequencies of people from 0, 1, 2, 3, 4, 5, it is actually regarded as Python. But take note, if 1, 2, 3, 4 is more than 5, then you can use Python. But if it is 1, 2, 3, 4, you can either use multinomial, or you can either use ordered logit. So I want you at your own to look at how ordered logit is being considered, and when making sure, when learning ordered logit, the logit does not give you the different variations, but now you actually collect the variations from the marginal effect. So I want you even to look at the marginal effect for that, so that you can even model something from that particular angle, given that you wanted to order certain things in that order, and then you look at the significance per order. So the command is OLOGIT. Okay, so you can actually do it in that particular way. Now when you're doing multinomial, I mean Python, you always look at the negative side. Now the negative side is the negative binomial. If we have got so many zeros, you must be able to look at negative binomial, which you actually say E start estimate GOF. After you have learned this particular model, then you can be able to say E start estimate goodness of fit. Okay, like that. I've forgotten the command. Let me remove this. Okay, yeah. So you just take E start GOF. So if you have got if this goodness of fit is significant, it means that the Python regression model that we are using, it has a lot of zeros which requires to be deflated. So the process of deflating the zeros, you use what is called negative binomial, which normally follow this particular command 106. So negative binomial is like a complementary kuti ukuko yalepeleka, because this is significant, then you actually go for a negative binomial, because in the Python there were so many zeros. Because if you can look at the table that we had, so there were so many zeros relative maybe to these other values. This is the one, so you can actually see that the difference between here and there, this is just the zero. But if this was like here, it means that it would have balanced, because the zeros could have been quite proportionate to these other parts. So to control for that, you actually use this command E start GOF, which is goodness of fit. Then it brings you the goodness of fit, and when the deviation probability of the goodness of fit is significant, then you conclude that there is inflated zeros. And if there are inflated zeros, then you actually go to the second part of the model and then do what is called negative binomial. So the command for negative binomial is nbreg. So this is actually how you actually do, and then you can be able to enter the command, and when you enter the command, it gives you the results, and that particular result is actually called the negative binomial. So the negative binomial, it appears like this. So you can now be able to make conclusions based on that particular model. Okay, so that's the most important part that I want us to actually discuss, so that we can be able to appreciate the different ways. So count dependent variable, we model them using count models, and one of the count model is Python complemented by negative binomial. And when you have got a dependent variable that has so many outcome, you must make sure you are either using multinomial, or you are using ordered logit, or you are using unordered logit. So I want you to look at the papers that have used these techniques, and then see how it is being used. Now in terms of the presentation, like in terms of interpretation, you can go on YouTube and then do annotate whatever you want to annotate, and then once you do the annotation, you can actually you can say annotate stata output using Python regression. Then you can say the statement, and it will teach you how you can be able to interpret. With that statement, I will stop there, and I will give you for each section, you have to have you need to find a question on your own, and then when you find the question, you need to find data from IHS, and then you should be able to model that particular data, and then you give me the results that you have presented to make it to spice it up. But I'll put it in writing so that everyone should not miss. Yeah, having done this, I think we can say that we can stop here at this particular moment, because if you can follow through, we have done so many things determining it at this level. I think it can give us a good run. Thank you.